first technique I'm going to show you is that of mixing of solutions in small test tubes. That would appear to be a very simple process, but mixing of solutions is a very, very important technique for success in this type of laboratory. Here we have a small test tube with a yellow solution. The solution is sodium chromate. I'm going to add a second solution dropwise, and so I'm adding a solution of sodium phosphate. And as I'm adding the drops of sodium phosphate, I may think that the solutions are mixing. However, the sodium phosphate is just sitting at the top, and I want to make sure that I mix these two solutions. To do so, I'm going to use a rubber stopper. I'm going to stopper the test tube, and I'm going to shake it once. I'm going to now open the test tube, take off the stopper, just in case there's a chemical reaction occurring that releases a gas. If that were the case, there will be a pressure buildup, and I want to make sure that I release it. If I notice that there's no pressure buildup, I can restopper the test tube, and now I can shake it well several times to make sure that my two solutions have mixed well. Let me make a point here that's very important. When a solution has color, it may still be a solution. We talk about color as one characteristic, and we can talk about a solution being clear or cloudy as a separate thing to observe. A solution could have color, as this one does. It's a yellow solution, or it could be colorless, just like water. But both of those solutions are clear. You can see right through the solution, as opposed to a solution that may become cloudy, and it could be white and cloudy, it could be yellow and cloudy, blue and cloudy. It depends on what's being formed in that particular mixture, and a cloudy solution indicates the formation of a precipitate. Another way we could have mixed this solution rather than using the stopper is to use a stirring rod, and I can mix by using a circular motion with the stirring rod. However, some individuals prefer the stopper because the stopper actually allows you to give the solution a good shake. Complete precipitation. Here we have a test tube with sodium chloride. Sodium chloride is table salt, so it's a solution of sodium chloride. And we're going to add to it silver nitrate solution, and we're going to form a precipitate of silver chloride. If you notice, the silver nitrate is in a dark dropper bottle. That is because silver nitrate will decompose in the presence of light, so we keep it in a dark bottle. We're going to start adding the silver nitrate dropwise, and as the drops come in, you can observe that a white precipitate is being produced. How much to add is always a dilemma, and after a while, everything gets so cloudy that we cannot see whether adding additional drops forms more of a precipitate. So what we need to do is place the solution in a centrifuge. A centrifuge moves the test tube very quickly so that it packs down the precipitate to the bottom, and then we'll be able to see the solution or the filtrate on top. We'll be able to add more silver nitrate and see if more precipitation is formed. So we're going to place the test tube into the centrifuge. The centrifuge has test tube holders that are made of metal, and they have a rubber cushion at the bottom of each to make sure that the test tube is well held and cushioned. We need to have the centrifuge well balanced. So on the opposite side of the test tube that I'm trying to get the precipitate to pack down, I'm going to have a test tube just with water to make sure that I have it balanced. So now I close the centrifuge and I set the timer, and normally half a minute or a minute is all that's necessary to pack down this